Well, hello, my friend. We are going to continue the 2017 free response questions. We are now on section 2, part B. Okay, section 2, part A was problems 1 and 2. You got a calculator. For this problem right here, there's no calculators allowed. And there are 4 questions. The good thing about this is that the math is slightly easier. We're not going to be popping back and forth with the calculator, back to the screen to the calculator. The work is a little bit more doable from an algebra standpoint. Okay? So let's take that calculator and smash it. If you have a hammer, smash your calculator into some pieces and send me just the number 2 key. I just want the 2 key. I collect them. I have a weird thing about the number 2. I'm kidding. Don't smash those calculators. They're a lot of money, especially if you got one of those new Inspires. Keep them. They are wonderful. Especially if you're not in college, you're a senior, you're going into college. Keep it. Well, my, ain't that a pretty little picture? That's the graph of f, kids. And number 3 states the graph of the function f consisting of 3 line segments and a quarter of a circle. Okay? 3 line segments, 1, 2, 3. I probably should do those different colors. And a quarter of a circle. All right? Is shown above. Let g be the function where g of x equals the integration from 1 to x of f of t dt. Right away, I'm looking at that x as the upper bound, and I'm looking at the variables in my integrand, what I'm taking the integral of, and it's a t. At some point, I'm probably going to have to take the derivative of that integral and replace the t with an x. If we put a number in there, we're good. Okay? But at some point, I'm thinking we're going to see that. But let's see what happens. Okay. A says, find the average rate of change of g from x is negative 5 to an x is positive 5. All right. So first of all, average rate of change, it just means slope. Okay? We want the average. We're really doing change in y over change in x. Okay, that's really y2 minus y1 over x2 minus x1. Or in calculus, we say t2 minus t1, and we find f of, well, they don't do t's, they use a's and b's, don't they, in a lot of the books. They say b minus a, f of b minus f of a. It's really all the same exact thing. Let's say this is my b, or my x2, whichever one you want to use. All right, and this is my a, or my x1, okay? I'm going to have to find that slope between those 2 points. Don't look at your graph. The graph is of f. We want this of g right here. So I'm going to take 5 minus a negative 5 all over, in this case, it's g, right? So it's g of 5 minus g of negative 5. Okay? So the bottom is easy. It's just 10. We got to figure out what these things are. And again, there's no use of a calculator, so don't freak out. Let's do this one. G of 5 means I put a 5 in for my x, from 1 to 5, because my x is up here, of the graph of f of t dt. Now, I don't have an equation for f. Remember, the integral is the area under the curve, from 1 to 5. Yeah, what's going on? That's weird. Like that? That. Wow, that was trippy. Anyways, x is 1 right here. 2, 3, 4, 5 right here. I got to find the area of this here. And a lot of people will just automatically go to trapezoid. I like triangles and rectangles. Okay? This is a height of 4, which means this is a height of 4. This is a width of 2. This is a width of 2. My triangle is 1/2 base times height. Half of 8, that area is 4. Okay? And the area of my rectangle is just length times width, 4 times 2, which is 8. If I add those together, this whole area is 12. It's 12. Okay, so now for here, g of 5 is 12 minus, we got to do g of negative 5. So I'm going to take the same thing here and throw in a negative 5. Okay, I'm going to integrate from 1 to negative 5 this time, f of t dt. But here's the thing. My rules of integration tell me if the upper bound, which is negative 5, is a smaller value, I can flip them and everything will be okay with one exception. All I got to do is negate the value right here. Okay, so that's what I'm going to do. Okay, so from 1 to negative 5, I'm doing the area under the curve. Okay, let's get rid of this mess here. My 1 is still right there. But this time, I'm going to negative 5. So from 1 to 0, negative 1, negative 2, negative 3, negative 4, negative 5. Here to here. All right. Triangle. 3 by 4. Okay? 1/2 base times height. Base times height is 12. Half of that is 6. All right? I'm going to focus on this little triangle right here. Okay? So 1 ends right here. I got to find the area of this triangle. That's 1. Okay? And it has a height of 2. So this triangle right here is half of 1 times 2. Half of 2 is 1. All right. Here is the, it's not an issue. It's just it's not going to be a clean number, but who gives a flying poop? This is a quarter of a circle. I know the area of a circle is pi r squared. But it's a quarter of that. It tells me it is made up of 3 lines and a quarter of a circle. My radius is 2. So 2 squared is 4. I have the pi in here, and I multiply it times 1/4. I told you the math is easy. Boom, boom. It's just pi. This area is pi. I add them all together. 6 plus pi plus 1 is 7 plus pi. That's my whole area. Don't put the pi in the, leave it pi. I mean, if you want, I suppose you can. I mean, for those of you that are freaking out, but again, you don't get a calculator. You can't put pi in a calculator, so you got to know at least to the thousandths place, 3.1415. Okay, again, pi is 3.1415926, blah, blah, blah. If I round here, that's going to be 3.142. Okay? Don't start, getting crazy. Just leave it pi. What do we say? It was 7 plus pi? All right? So, I mean, that's an okay answer, but you guys are in calculus. Let's distribute that. So I get 12 minus 7 minus pi over 10. I can combine these two and end up with 5 minus pi over 10. There you go. That's the average rate of change of g from -5 to +5. I mean, I could split up that fraction even more, but I mean, like I could put 5 over 10 minus pi over 10, but then you're going to have 2 fractions, 2 denominators. Take it easy, champ. Take it easy. Save some of that math for later, okay? Let's go on to B. And B says, find the instantaneous rate of change of g with respect to x at x equals 3, or state that it doesn't exist if you can't find it. All right. First of all, let's recall what g was. G was the integration from 1 to x of f of t dt. If I need to find the instantaneous rate of change, that's the slope, but that's a slope at one point. It's not the average. That is the derivative slope, the slope at one point. Okay, that is the derivative. So I'm going to take the derivative of g of x, okay? And I'm going to have to take the derivative of this integral. So g prime of x is, all right, I said when this first started that with this x here and this t here, I have a feeling we're going to have to take the derivative of it, and here we go. Derivative and integral cancels. This x goes in for the t. When the integral goes away, so does the dummy variable. So it's really f of x. The equation for g prime of x is just f of x. That might come back later. They like to layer things. So now let's go back up here. We want this at x equals 3. G prime of 3 means I'm going to just want f of 3. All right, well, let's go back to our graph, because we have the graph of f. Let's find out what that coordinate is. No, man, who made this mess? What a jerk. All right, anyways, 3 right there. Now, don't look here and be like, oh, my God, it's a corner. I can't take. Stop it. I just want f of 3. Remember, that's a coordinate. What is the y value of this point? 4. 2, 3. It's 4. F of 3 is 4. Okay? So I go back here, and I say, well, f of 3 is 4. That was a nice, easy one. C, 3C. Notice I have a picture of the graph here because it's going to be nice to reference. On what open intervals, if any, is the graph of G concave up? Justify your answer, which means show your work. All right here, people. So concavity is the second derivative. If it's concave up, I want to see where the second derivative of G is positive. I know the first derivative of G, we just did that, was f of x. But if I want the second derivative, that means I also got to take the derivative of the right side. The second derivative of G is the first derivative of f. If I want this to be positive, I also want this to be positive because they're the same things. Okay, they're equal. Okay, so the derivative of f is the same thing as saying the slope of f should be positive or increasing. Okay, let's look at any intervals where f, this is the graph of f, so I'm going to look at the slope of f. Ready? From here to here, it's increasing. That's nice. That's obvious. From here to here, it's increasing. That's it. So we're going to go from -5 to -2. That's one of my intervals. And then from 0 to 3. Oh, that's it. That's a nice one. Okay. So from -5, we're using, does it matter if I use x? Oh, yeah, x is right here. So x -2. Okay. And from 0, x to 3. There you go. So justify. Here it is. If the second derivative is equal to the first derivative of f, then there's a slope where the first derivative of f is increasing. Justification, right there. And our fourth and final part of number 3, 3D. Find all values on the interval from -5 to 5 for x, at which G has a critical point. Classify each critical point as the location of either a local minimum, a local maximum, or neither. Okay, justify your answer. Critical points. Okay, that's where the first derivative, is equal to 0. Okay, and we will first find those. And critical points are where you can have, you don't have to have a minimum or maximum there, but those are the possible places where you can have a minimum or maximum. So let's find those critical points, and then let's figure out if they're minimums or maximums. Man, in part B, we said that the first derivative of g is f of x. That has come back a couple of times to help us, okay? Because they want us at which g has critical points. So I'm looking at the first derivative of g, okay? So I want to figure out, well, where is this equal to 0? Which means, where is this equal to 0? Again, I just put that right there. I don't have an equation, but I have a graph. This is the graph of f of x, okay? So any y-coordinate is f of x. So I got to look where the y is 0. The y is 0 right here. It's 1, 2, 3, -1, -2, and so forth. Anything anything on this line right, I'm sorry, I got to do that every time I do the dash line. Right here and right here, f of x equals 0 because that's where y is 0. This is at -2, and this is at 1. Those are the two locations for critical points. Okay? Those are the two locations at critical points. Woo! Okay, no, we're good. We're good. We're good. I was looking at something. Never mind. So, this happens at x equals -2 and 1. All right? Now, at those points, I need to figure out if they're minimums, maximums, or neither. All right? So I'm going to erase this stuff right here. And here's our critical point. We're at 2. Here's our critical point at 1. Okay? Now, in order to have a maximum, I need to go from a positive slope to a negative slope, right? And the critical point is right in between. Same theory with the minimum. I have the critical point in between, but I need to have a negative slope followed by a positive slope. Okay? So what I need to do around these critical points, slope is the same thing as derivative. So I need to figure out, is the derivative for g positive, and then does it go to negative? Does it switch signs from positive to negative, or from negative to positive around these critical points? So if I'm looking to see if g prime changes signs, I'm looking to see if f of x changes signs. Let's look at our graph. F of x is y. So I'm ultimately going to look to see if y changes signs around those critical points. Oh, I love to get the green and the red whenever we're doing positives and negatives. We had stated earlier that y is 0 right here. Okay. Anything above the x-axis, wouldn't that have a positive y value? It would. If it has a positive y value, it has a positive f of x value. If it has a positive f of x value, that means the derivative or slope is positive, okay? And likewise, anything below the x-axis, I know that wasn't a dashed line, but there were, little negative signs. The y is negative, so f of f is negative. So the derivative of g is negative, okay? So, highlighter time, I love you, highlighter, yeah. Okay, I am below the x-axis here. Boom, they're negative y values. And then I hit a critical point. But after that critical point, it still stays negative. Okay? It does not change signs at 2, which means it doesn't go from positive to negative or negative to positive. So at here, there is neither. How come? Because the derivative of g, the first derivative of g, does not change signs through the critical point of x equals -2. And by the way, that should be -2. Okay, so let's continue on our graph right now. We need to make that statement for all of our critical points, and we have 2 of them. So we got to do this one next. Okay? Highlighter, highlighter. Okay, now we're positive. We're above the x-axis, positive value, which tells me right here at this critical point of 1, I change signs from negative to positive. So if I go from negative to positive, I need to have a minimum there. Okay? That's a minimum. Okay? Okay, kids? No? So now there is a minimum at x equals 1 since g prime of x changes, I was going to say switches, would have been the same thing, changes, sorry about that C, kids, I really can write, changes from negative to positive through the critical point of x equals 1. Okay, so here are 2 critical points. One of them does not have a min or max because it does not change signs. One of them does have a minimum because it goes from a negative derivative or negative slope to a positive derivative, which is an increasing or positive slope. That was kind of harmless. 20 minutes with explanation. I mean, some of the other ones were going like 30, 40. We were like, another third of our time spent on that. Okay? Give me a like. Give me, when I say give me a like, I mean just hit the bell. You don't have to find me and see where I live, and then like when I walk out of my garage in the morning, be like, hey you, I like you. I just wanted to let you know. I would say, oh, that's very special, and then probably try and run you over with my car when I leave because you freak me out and scare me. But ring the bell. Follow me. I'm going to do number 4, 5, and 6. Still have their own video coming up. I got to create a playlist so these all come in right order. Like me, bell. Follow me. You know what I mean. Don't follow me. I'm not even going to get what happens if you're going to follow me at my house. So I'll see you. Bye-bye.